Well, hi, good morning. Thank you for joining me in my shop here. It's August 3rd, pretty gray day outside. And look at this thing here. So today we're going to be looking at this together. I can't promise anything about what we're going to be doing here in terms of making use of this guy or anything. Let's take the top off. Very unusual. This whole thing is quite unusual. Oh my gosh, what is this? Well, I think it's very obviously a tube tester, and quite a nice looking one. AVO vacuum tube tester type VT161. I have researched this, and I did it some time ago. I obtained this about 6 months ago, and I looked into it then. I couldn't find much out about it at all. But what I do remember is, I'm gonna have to hunt this down again, is a guy having a discussion with somebody else about one of these, which he had. And I think what he was trying to say was this is a prototype or a limited production run of this particular model of tube tester from the company that did it. I'm sure their name must be AVO. But they only produced some limited number of these, and then there's an earlier model which is quite different from this. Then there's a later model which contains all the same circuitry, but the layout of the whole thing is different, as if this was their first attempt at the circuit, and then they improved the layout of the box, probably got it smaller and lighter and all that kind of stuff. This is quite so consequently there doesn't seem to be any real information about this tube tester. What am I doing here? Oh, well, look at that. I was thinking, well, that's great. Yeah, well, we're way ahead here. Way ahead. I got a way to plug it in. Huh. And that's a North American plug there. So I had noticed on the back here, let me just do it like this. There's a socket like this, and I thought, oh my gosh, I'm gonna have to do some wiring to power this thing up. I've actually got a power cord now. So I was saying, before I got excited about the mystery box, there's very little, next to no information specifically on how to use this, how to operate it, what the numbers here mean exactly, as I remember it. But perhaps I've got it wrong. Now this thing just looks like it's full of all kinds of interesting capabilities. Anode volts, screen volts, it has the numbers right on it. Set it to 100. I mean, this is quite different from your, this is much more like a laboratory instrument, more than a repair shop tube tester. 1.8 to 80, 0.625 to 117 heater volts. Meter switch. Circuit selector. Set looks like frequency. Set frequency. H continuous. I don't know. Insulation. AR, SR, CHR, CH. No idea what these things are. Gas. We have to be a gas test, I guess, for the tube. For a tube. Set frequency here. So I guess you have 4 frequencies. Frequency of what? I don't know. Some kind of frequency. Electrode selector. Electrode selector. Maybe this is attaching the meter to a particular electrode so you can read the, because what have we got? We got CH, that would be a cathode or a heater. Okay, I got that figured out. And we've got A1, A2 anode, and D1, D2 diode. I don't know what don't know. Negative grid volts. Again, it's calibrated right in volts. There's a switch here, ×1 or ×2, so that'd be like -5 grid volts there. Mains. So that's a worrisome thing. When it says mains, that's a European or British statement. You never see this in North America. So is this a 240 volt machine? But it's got this kind of plug on it. Somebody brought this over and put this plug on it and plugged it in. The machine's all burned up and now it's here. I don't know. What do we got here? Danger, 440 volts. Removal of this cover exposes live anode links. Oh, this must be links to, so you can make current measurements maybe? There they are. The links. Everybody's tight. AAA. Well, that's all. It's all pretty weird here. Look at this control. GM range, 10 to 60, 3 to 18. What kind of GM is 10 to 60? Set GM. Oh, here we are. So here's a spot on the meter that says set GM. GM calibration set to 1. Read GM. Oh boy. Oh my gosh, I'm sorry about that. I've got my camera not aimed properly. Darn it all. Well, let me go over that really quick. So I was just looking at I apologize for that. So GM range, set GM, read GM, calibrate GM. So set to 1, I guess you push this button and you set to somewhere on here. GM range, like 3 to 18, 10 to 60, and that's set GM. So I think this is, there's a set GM right here. Maybe it's in set mode kind of all the time till you push this or push this. Got all kinds of tube sockets here, including a couple that I don't know if I recognize them. Well, there's every kind of tube socket you can think of on there. And very early ones. Why would they bother if this was some device put together for a specific purpose? It's definitely a general tester. Valve pin. So Valve again, the British. I guess AVO is a British company. I'm guessing. Valve pin selector switch. TC1, TC2, 13 different settings. Valve pin. So you assumably this is pin number 1, and you're setting it based on this number to plate or I don't know. I gotta find those documents. I gotta hunt down those documents, and we gotta take a look at them and again see what goes on here. Wow, this is quite the tube tester. This is very unusual, and that there's sort of the ability for you to just select the particular voltage in that. That's cool. Okay, so you can see I've typed into Bing here, in fact, what I have on my bench. AVO type TV161 tube tester. That's exactly what it's called. And what do we get? So we're going to get information about the 163, and we're going to get information about a 160 down here somewhere. So let's take a look. So I believe, yeah, this is the predecessor. No, is this the predecessor one? I don't think so. This is the successor machine that came after the one that's on my bench, and I believe the one on my bench I'm kind of making this up, was a prototype that led to this marketed machine, which they call very rare, in excellent condition. 163. Now here's 161, but these aren't 161s, these are 160s. Do you see they look different? So we got 160, and we got 163, no 162, and I've got a 161 on my bench. Now, what are the chances that I can find that document, which I'm hunting for, where somebody talks about a letter they got from a person who was involved in the production of the 161? And there was a lot of interesting information in his letter. So I'm going to try to find that somewhere. I think this is what I read a few months ago. I'm pretty sure of it here. UK Vintage Radio Repair and Restoration. AVO VT161 tube tester. That's exactly what I've got on my bench here. And look, here's some pictures of it. This is what I have on my bench. This guy right here. This guy. So what did he say? So bear with me. I'm just going to read through this. Did the AVO VT161 tester ever make it to market, or was it only ever a prototype? It looks like a very early version of the VCM 163, with a long set of rollers, but only 1 meter. I spotted the papers on this beast in the very helpful IET archives today. Well, what's that? IET archives. On a chance visit. They are mixed in with those on the CT160. I suggested a few alterations to the entries to highlight this rare beast. It's not like AVO to use the US nomenclature tube for our British valve. The papers contain about 8 photos, a set of hand-annotated drafts for a manual, and a few sketches for diagrams. Is there any more information out there? They are happy for me to publicize this photo and materials. This photo and the other materials are of course property of the IET, and they've asked kindly any reproduction contains a reference to the IET archive. I gotta look into this IET archive. Any commercial reproduction would need their written permission. This seems eminently sensible, given how helpful they've been on archive materials. Okay, the next fellow says, yes, very interesting. Clearly designed as a more portable instrument than the traditional design. It does not have the AC mutual conductance facility, which could either be a simplified version of the VCM 163 or an intermediate development. The apparently unconnected empty box at the top right could possibly be for GM circuitry under development. No, the empty box is where the power cord was hidden. They didn't open it and find the power cord in there. The GM switch panel below would then be updated with a second meter. So they're just describing the process of going from what I've got on my bench to the next model, the VCM 163, which was marketed. It would seem to be a prototype that predates the 63 and the CT1 and the CT160. Well, it wouldn't predate a 160, would it? It may be that marketing considerations then led it to it being decided not to combine portability with versatility and to produce the two models. Again, not sure what he said there. Sorry I'm reading this to you, but this is how it goes, right? I have acquired scans of the material referred to above on the prototype AVO VT161, which clearly shows that it is the predecessor to the VCM 163. The material contains a lot of handwritten notes at early stages of the development of the 161. Clearly shows it works in the same way as the 163, and also that the early simplified circuit for the GM measurement are identical to the 163. If you look carefully at the photos, you can see that they show the amplifier. They show the amplifier and oscillator board to the left behind the transformer. Since the prototype is based on the CT160, the controls are almost identical on the tilted front panel, but on the top there are a few new switches and push buttons that work like they do on the 163. When you make a, I guess that would be anode current measurement and GM measurements, like when the oscillator and the amplifier is used for the GM measurements, oscillator and amplifier is used for the GM measurements. The large PCB-TP, the right, contain the same components as the VCM 163, a different configuration. You can easily spot the 700 ohm load resistor at the far back, the 700 ohm blah blah blah. The roller switch is the same as the one used in the Taylor 45D D2 series of valve testers. Taylor, never heard of that. Most of the rest of the electronics comes from the CT160, except for the GM measurement parts, which are the new pieces added to the design. An almost identical design of the oscillator amplifier boards found in the AVO TT537 transistor tester, which I wrote here. The difference is the TT537 uses a 1 kilohertz signal, whereas the VCM 163 uses a 15 kilohertz signal, and also that the amplifier and oscillator are connected via transformers in the VCM 163, not used in the TT. Wow, okay, are you getting all this? It's starting to kind of leak through my head here. If anyone has photos, vacuum tube tester is screwed on plate. That's true. On the one I have on my bench, it says AVO vacuum tube tester, and that's a screwed on plate. The rest of it uses the word valve. It uses the word valve and anode, not tube and plate. The internals look military spec. I think this is a thoroughly British development, possibly trying for a NATO contract. Now that's the kind of thing I'm thinking, but I'm probably thinking that because I read this 6 months ago and it's still in my head. It says AVO military tube tester in the TypeScript documents, so it's definitely meant for the military. It also says prototype CT160 on one page, but all the pictures name the unit as the VT161. I gotta get this document. Most of the internals exactly the same as the VT160, picturing oscillator, blah blah. Oh, what are these? My manual for the TT is an extra page with comments, so that's, I think you'll find the VT160 virtually identical to the MPK, blah 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 blah. For the TT I've attached the photos and the single circuit board, so okay, so that's for links to something slightly different. Now they're all caught up in this TT537. I gotta look at this okay, very quickly. We gotta find out what this is. This IET, where to go? IET archives. Oh, let's take a look for that. IET archives. IET archives. The IET Institute of Engineering and Technology. Okay, that makes some sense. Search the IET archives. Sure. So it uses cookies. Sure. Go at it. Join us career wants all the IET Institute. Searching the IET archives. Our archives are so extensive. Are extensive. So to make them more accessible, we created an online catalog so you can narrow down your search and pinpoint exactly what you need. Oh my gosh. Okay, so I'm not going to do this live because I got to learn how to search through this. I'm going to try to find the documents in here that relate to the tube tester on my bench. I probably don't have this right, but it looks like the Institute of Engineering and Technology holds a database of vast amounts of really interesting stuff, handwritten notes and all kinds of stuff from all kinds of technology things. But to get them, you have to identify them here on their website, and then you send them a note or something requesting they send you the stuff. I don't think you can just click and download it. So here's what the best I could find. This is for the VCM 163, which appears to be the commercial version or the production version of the thing in front of me on my bench. It looks different, but appears, according to what I've read, works the same way, whatever that means. VCM163, all they have here are 4 photographs of it. So that's not going to be too helpful. What I really need to find now is the manual for the 163 and see if I can look at the manual and relate it to the machine on my bench. So that's what I'm off to do now. Well, here's the operating instructions for the Type 163, which looks like that. And you see, it's quite different from what I've got. It's a very compact, portable machine. Tubes go in the top here. It's actually well thought out, much more attractive than what I've got here. But apparently, it works the same, except look, it's got 2 meters instead of 1. I've got 1. So apparently, maybe the operating instructions, which is what this is the manual for it, maybe this is going to give me enough hints that I can figure out what I can do with the one on my bench. Oh my gosh, this is 23 pages long. Let's just read the overview here, but not this part. Yeah, so we're reading this part. All the advantages of the Mark IV. Yeah, they're going to mention the 161? I doubt it. This instrument is a double-purpose valve tester as follows. It provides a rapid diagnosis of the condition of the valve under test, the instrument operating as a simple go, no-go device. Sufficient data may be obtained enabling an operator to plot static and dynamic characteristics or similar information using selected anode and cathode loads. Valves with any number of base connections up to 13 and up to 2 top caps can be tested. The instrument will check the majority of the receiving valves and some all transmitting valves. Whilst good-bad testing on a semi-production basis will undoubtedly be one of the main uses for this tester, it is certain the instrument will find considerable use in laboratories and service departments where engineers and skilled personnel will be available, and where more precise details of valve performance can be used to advantage. To this end, facilities on the tester enabling these characteristics to be plotted over a wide range of voltages, these being readily available from the calibrated front panels. At the same time, mutual conductance will also be continuously displayed on the second panel meter. So I think that's it right there. Continuously displayed on the second panel meter. Whereas in this unit, you have to push buttons to get it to display the mutual conductance, whatever operating conditions are selected. The AVO valve data manual, which is supplied, contains all the AVO valve data manual. That's going to give me all the valve settings, and it's not part of this. Not part of this. Okay, let's just scan down through it at this point. Operating principles, basic circuitry. Well, that's pretty basic. Block diagram, basic circuit for transconductance, technical information. Yeah, this really is an engineer's tube tester. This is not the repair guy's tube tester. What's all this stuff? The valve holder panel and valve pin selector switch. What? Okay, all valve holders. A valve holder, is that what they call a can't think of the name of it now. I got valve holder stuck in my head. Oh, those British people. What's all this? This is all instructions. This is American small 7-pin, American 6-pin, British 7-pin. Interesting. Valve holder. We would call that a socket. Wouldn't we? A tube socket? Links on the valve holder panel. Function controls. Yeah, this is not made for the TV repairman to jump in your house and test a tube and sell you a new one. Oh, look what's coming here now. Valve pin selector switch. or some. These are tubes. EL84, ECC81. Why did they put those in there? There's just a few tubes. Procedure for setting up valve-based connections. Excuse me. Okay, some reason they're showing you these ones. Perhaps these are all examples of types of tubes or classes of tubes. Using the AVO valve data manual. Okay, shows you how to use the manual. Dissimilar treble pentodes. Huh? What's that? Setting up the instrument from manufacturer's data. From the manufacturer's data. So that means I can open up my tube manual. Oh my gosh, look at this. Oh boy. Yeah, it'll just take me a couple minutes to learn all this stuff. Valve characteristic measurements. Wow. Okay, where are we? We're about 2/3 through here. These valves are tested as two separate assemblies, separate data being given for each assembly in the valve data manual. The electrode selector should be set to A prime when selecting triode section and A double prime when... Oh boy, okay. There's an awful lot here to know before you can use this effectively without making dumb mistakes. And for me, dumb mistakes. There's a circuit. It's got transistors in the circuit. It's a transistorized tube checker. That's kind of nonsensical, isn't it? And here we come to the end. Dover, Kent, England. AVO set Dover, telex number, printed in England. Okay, so we've gone through the manual. We know what's in it. Can this really be applied to this tube tester? Gee, I don't know. At this point, I see what the journey is to get this to go. What would we try next? What would be the next thing? If I wanted to do the next thing, somewhere give an abbreviated list of instructions. But before switching on, the full operating instructions should be read and always used for reference when testing unusual. Oh, so here we are. I got a little fantastic. So I'm going to read this, study up. I'm going to plug this thing in and see what happens. Well, just continuing the journey here. So here it is, the AVO valve data manual. Now there's many editions of this. So let's see what it says. CT160, VT160, and the VCM163. So basically all their tube testers are following the same manual. I guess that makes a lot of sense from a manufacturer's point of view. Every time you release a new device, do you want to release a whole new data manual? I suppose not. Oh my gosh. The TTT. That's the triple triode. What's the third T? Symbol internal connections, all kinds of symbols, and here it is. So that's the version that came afterwards. He's got his tube plugged in. He's got his hand on the controls. He's wearing sunglasses, so it appears. Yeah. Do I have to get sunglasses to operate this? So I'm not going to go through this with you. Obviously, this is a very long, very long manual. Instructions on how to use the manual. Does it mention 61? See, AVO instrument covered by this manual are, it doesn't even mention the 61, the 161. And I think the reason for that, they never put it on the market. I've got a prototype machine here. Perhaps they built a couple of these and then tried to sell them as was suggested. Try to get a contract with NATO or some other military contract, and they were unsuccessful, I'm guessing. But maybe they were successful, and maybe they made 10, 20, 50, 100 of these. I don't know. How did this end up in Canada anyway? That's a good question too. Maybe there's a NATO connection there somehow. I don't know how it ended up here. How did it end up in my shop? That's a really big question. Valve characteristics are given directly in tabular form, and pin connections may be obtained by decoding the selector switch settings for the VCM163. I'm not quite sure what they meant by that. Oh my gosh, so there's an awful lot here. In here. But in here I should be able to find the settings for the tube I have. Here they are. Here they are. Okay, so I've got a tube here that I think might. I've got 4 50C5s here. Just happen to have them because of another radio repair I did. Ooh, what happened? Let's see if what happened just now. What happened? I think I went back. Oh, yeah, here we go. So we're going to look for 50C5. Now, is that going to show up in here? That's what we're going to find out. 30, 35, 36, 41. What are all these tubes here? Look at, it's got like tube number 38, 39. Well, if it covers tubes like that, those are real old tubes. 50, 50, 50, 50C5. There it is. There's the number settings. If I can just kind of figure these out. Very good. This is page, well, we don't know what page this is. It says it's page 59. So I'm going to print this guy out, and this page, just this one page, and we're going to try and set the tube tester up. Good luck. Okay, let's plug it in and see what happens. If you're noticing a roar in the background of the video, in the sound, that's air conditioning running in my house. Okay. There's key marks on the outside here. There we go. So I'm going to plug this in on the assumption that whoever put the plug on the end knew what they were doing, and the machine has been set for North American voltage, 120 volts. We're going to put this in here. I'm going to use a dim bulb system to prevent a disaster from happening. Now, a little bit of practicing here. So here's the on-off switch. There's no power supply here, so you would turn it on like that. I assume this red light comes on at that point. And then we have these different labeled switches. The labeling here appears to be a little different than the labeling up here, but maybe I can sort it out. We have the numbers to be set here. There's 13 of them plus 2. 13 plus 2. Selector switch, selector switch. 13. If we take a 50C5, not that really matter. Here we are. 13, eh? So there's 1, 2, 3. There's 9. There's 13. 13 numbers right here. 13. Perfect. Perfect. What are these numbers? Selector switch. Selector. I see. VCM 163 only. VCMs mark 1 to 4 plus VCM 160. So I believe I'd be using these numbers. Of course, look at, there isn't 13 numbers here. There's only 13 here. So it's got to be this side. Very good. Figuring it out. And we have all these settings here. I think I can figure all these out. This base number, like, is there more than one place that I can plug this in? I don't think so. I think the tube I have, let me grab one. Here, this is a 50C5. You can only go into this socket here, like so. So there's no other choices there. Okay, next step will be just to turn it on. I assume we can turn it on with nothing plugged into it, like no tubes in it, and see the red light come on. Okay, so I'll put this there. So again, I'm using the dim bulbs that are sitting over here. And maybe I should set these low for some reason. I don't know why, but I feel like I should. Maybe this should be set to test. There's a test setting here. I'm just trying to set these things as neutral as I can. Frequency selection, I have no clue of that. And screen volts are set. Everything's set. Okay, here we go. Ooh! Ooh! Did somebody hear that? Anybody hear that? The machine farted. I turned it on. try that again. There's a relay snapping in here is what it is. Whack. Nice, beautiful red light here. I'm about to light my room up with it. Wow. So good. So far so good. So we'll turn it off. And we will attempt to set these now. So if we were setting them, we would take the 50C5, which is right there, and we would go 1, 4. Yeah, see, this is not a high-speed tester either. I mean, if you're in somebody's home trying to fix their TV, you wouldn't want to pull this out and do what I'm doing now. 3, you'd want it to be much faster. 3, 4, 7. 7, 8. Go the other way. 8. Then all the rest are zeros. They're all zeros. And then it gives this top cap. It says 0, 0. So top cap, I'm assuming it's coming from here. It says TC1 and TC2. These are little pluggy things, and I remember seeing down here pluggy things. What are you talking about here? Way down here. So this little guy would probably go in here and on top of the tube, but the tube we're testing does not have a top cap. And what did I do with the tube that we're testing? I down here. So we have these set. Now, all of the rest of the settings here. 50C5. So obviously we're setting the heater volts to 50. There's 2 scales on here and a switch. There's a dark printed scale and a light printed scale. And I'm finding 50. 50. Where am I? There's 48. There's no 50. Well, that's kind of crummy. There's a 70, a 48, and a 40. 80, 55, 45. I guess we'll go 48. So we pick 48. This is the heater volts. Yeah, 48 is a little less than 50. And we go on the light side here. Okay, that's done. 50C5. The next thing is VG1. G1. Okay, VG1. Uh-oh. G1. So we've got G1, we've got A, G2, and some current settings here. So VG1, wouldn't that be the grid? So that's what they're really talking about. Then it's set to 7.5, and they don't bother with the negative sign. And these all look like grid voltages. They're all like, 15, 7. In this case, it's 7.5. So we'll set this to 7.5 on the belief that's accurate. So times 1 here, 7.5. The next thing is the V on the anode. So that'll be this one, 150. Okay. And the next one is the V on G2. G2 is the screen. 100. Oops. 100. And the next thing is IA in milliamps. So this is the plate current or anode current or just a current through the tube. Well, why is it? Is it telling me that now? I'm supposed to set that? I don't set that, do I? There's no setting for that. That must be a reading you get off one of the meters, I'm gonna guess. So this says, so what does that? It says 41 for the IA in milliamps. 49, sorry, 49 actually, 49 milliamps. That's got to be a reading. The next number here is GM, and milliamps over volts. 7.5. That it should be like 7,500, shouldn't it? So maybe they don't want to write all the zeros over and over and over here. So I think that's what's happened here. So it says 7.5, but it's GM is 7.5. You throw the tube away. Okay, 50C5, and then over here is the base, B9A. That's probably the one I picked there. It's the only one that can go in. And then the last thing is type P, type P. So 50C5 is a type P. Well, we know it's an output tube. Power, is that what that means? P? I don't know what the P. I don't know what the type. Is there a type setting on here? There isn't any type setting. So I don't know why they're telling us that. So over here, I'm going to order the short instructions now on how to set this stuff. Set frequency, I think is what that says. And I don't know, like, why wouldn't you just set it? Or why do you need a setting here? What's that going to do? Set. I don't know. H, continuity, heater continuity. So this is a heater continuity test here. That's what that is. Then we have insulation. This is the shorts test. So it says A over R, S over R, CH over R, and C over H. So this would be the between the anode and what's the R? What's the R? I don't know, but there's R every time. So cathode. I don't know what the R is, but that's what that is. That's going to be the leak test. They call it insulation. And then you have the test setting there, and then we have a gas setting if you want to try a gas test on the tube. Okay, I think I figured this out. Electrode, selector, meter switch. So this is all for the meter. So you can make the meter show you anode 1, anode 2. What would that be? Would that be the G2? Why wouldn't they put G2 here? So it must be something else. C over H. The cathode heater. Cathode / heater. Don't know what that test would be. Maybe it's in the manual, the 150,000 page manual. Okay, I've got all this figured out here now. What about up here? This is a weird area here. What's this red light here? What's this red light for? Is that a warning light? I don't know what that is. So again, so we have this calibration thing set to 1. And this must be 1 right in the middle here, I would guess. Is there any other 1 on here? And it's kind of suspicious. It's right in the middle. That's not a... Wait a minute. What's going on here? So we got 0.225, 0.5, 1, 2.5. Yeah, that's a 1. That must be where it goes. So if we want to try this, we can do this. Set to 1. The GM range. The range is, again, these small numbers, 10 to 60, but that's not what, GM is in bigger numbers. Set GM. I don't understand what this is. Okay, I'm going to find some more instructions. Let's see if we can figure out what's going on here. We're almost ready to test this tube. Actually, we're testing the tube tester. That's really what we're testing here. Okay, there's the short list of instructions. If you are not willing to read the full manual, and that's me. I'm not going to read the full manual, not at this point. Let's run through these steps. There's 1 to 6 and then 1 to 4 afterwards with a separation. And it says something right over here. All valves. Okay, don't know why it's saying that, but okay. Check mains, adjustment tap, and connect main leads to supply. Did that. Check. Set circuit selector to check and electrode selector to A. So in doing that, I have a set circuit selector to check. Circuit selector to check. There's no check on here, but there is a test, so we're going to put it on test. And electrode selector to A prime. electrode selector. There is no A prime, but there is a A1. So I'm going to assume that's the same thing. So that's set. Set heater volts to value indicated in valve data. Oh, yeah, I did that. Does it say 50? It says for a 50 C5, it says set to 50 when there's no 50 selection, but maybe they changed that in the later version of this after somebody complained or something. I don't know. Who knows? Heater volts. So I've set it to 48. So yeah, 48. Set grid screen anode volts to, I did that. Set valve pin selector and some valve data, I did that. Ensure that the links are tight. Huh? What? You have to ensure the links are tight. Ensure the camera doesn't fall over here. But let's ensure the links are tight. There's no power in this machine. This is a crazy thing to do. Sounds like, you know, risk your life checking these things when you're not. Danger! Danger! Okay, let's continue reading here. Set valve fit. Okay, with leakage switch set to this thing, tilde. Don't they call that a tilde? Switch on and adjust pointer to position by means of set switch. Set the thing switch. Set. So I think this is what they're talking about here, I believe. These two controls. So this one would be, for some reason they told me to put it on check. There is no check that I know of. I thought it was this one. Now they're telling me to put it here, so something a little weird. And then these are the set controls, and where are you supposed to put that? Adjust a pointer to position by means of set switch. Adjust the pointer to what position? What position are you supposed to set it to? Okay, I don't know. Okay, not sure what they're talking about there, but when we try it, maybe we'll find out. After you've done that, oh, now you insert the valve and make any top cap. Okay, there isn't one for this tube. Fully rotate leakage switch, check heater continuity and insulation on all other positions. Okay, be turning this switch all the way through these things on the way to test, and on the way, if the meter jumps up, leak. I think that's what it's saying. What else you got here? Check heater continuity. Set circuit selector to check H to measure leakage with valve hot. Fully rotate leakage switch. Check heater continuity and insulation on all other positions. Set circuit selector to check heater. Check heater. Check heater. Where's that? So we have heater continuity here. So is that check H? Okay, so now we're in the check H position. Measure leakage with valve hot. To measure leakage with valve hot. Turn circuit selector. Well, would you ever measure it with the tube not hot? Turn circuit selector to. Oh, I wonder if turning this turns the heater on the tube once you get up here. Maybe on the set switch the heater's not on. I don't know. So you run through, check. You end up at the test position. Set circuit selector to. Oh yeah. Turn circuit selector to CH insulation to measure leakage to heater cathode when the heater valve is not. If valve is indirectly heated, I believe it is. I believe there's a cathode in that tube. Triodes, double triode, double, all these other things. A similar combination. Anode, what's this? Anode current, set electrode switch. Oh, this just keeps on going. I thought it was just these. There's a whole bunch more to do. Anode current, set selector. I think I can turn the unit on at this point and get down to the bottom here, doing the leakage test or something like that. I think we can get through this already. Okay, so I have all these controls set. Right? No, I get this back to here. Back to here. Set. I think we're ready. I think we're ready. It's a transistor device, so it doesn't need to warm up as such. So it says, when does it say turn the machine on? Turn doesn't really say that, does it? Okay, so insert valve, make top connection required, fully rotate leakage switch, check heater. So it just starts telling you to check stuff. Can't check anything without it being on. Okay, we'll do that. Here we go. I flip this on. We watch for the dim bulbs over here, and watch for this thing to take off like a rocket, which I don't think it's going to do. I think we're A-OK. Supposed to do the set thing after we turn it on. Here we go. So the meter's gone nowhere at all. Have I changed this? It's making this light flash. Meter's going nowhere. Is it who knows? Is it who knows? It is who knows. So we'll just pick this eeny meeny miny mo. Let me just back it up here so you can see what I'm doing. I'm moving this guy around here. Watching the meter. Notice this red light's not coming on. Okay, no idea what's going on here. So we're going to check for heater continuity. Is that really the next thing to do? Read the manual, Jim. Fully rotate leakage switch. Check heater continuity at HC and insulation on all other positions. Set circuit selector to check H. So H. Wait, check H. Check H. There's a C/H here. Is that check H? Or is that cathode? That's a cathode versus heater leak. Here we go. Whoops, I went one too many. Slow her down. Is this thing even heating up? Appears to not be heating up at all. What have I done? These are controlling... is that a bad tube? Put in a tube with an open heater. Let's try another one. This should probably be set back to set. I should have tested one of these to make sure it was good. I heard a little pop there, I think, when I put that in. So I think I heard the heater go. But come on. There's nothing there. Nothing is there. This might be the end of the whole test here. Okay, the meter switch is set to anode. Meter scale is, oh, there's a IA here and a DR on this side. So DR, what would that be? DR. Maybe a resistance thing? And then there's a neutral spot. Right there. You put it there, it's nothing. The meter is off. Maybe I should have had this over here. Oh, this is scary stuff. There's also a cathode heater setting here. So the meter can read these different voltages. But it's not reading anything. But I have the unit on and I have the voltages set. So I don't think we want to put the meter switch on this current IA. It's going to read current through the tube. We'd rather see voltage, not current. So is that this other side? It goes up to 180. But the voltages go way beyond 180 over here. Somebody quickly help me out on this. What's happening? What is happening? Okay, so we'll set this on a fairly sensitive setting of IA, of anode current. Of course, the meter's not going anywhere. And it looks like this is not heating up at all. That's 2 tubes that have not heated. Okay, we'll check these numbers here. 50 C5. These are 50 C5s, aren't they? That's a really good thing to check. I'm pretty sure they are. Where's the label? No label. Come on. Give me some certainty here. Oh. 50 C5 written right on it there, so there's no question of what the tube is. Check these numbers. 50 C5. 1, 4, 2, 3, 4, 7, 8, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, all the way to zeros. Get the impression that this doesn't work. And we're running it with 116 volts, so it's getting the light. It looks nice. The light looks nice. I like that. Certainly the meter movement appears to be okay. We don't even know if for sure that the meter works. We haven't seen it go up at all yet. Can we not get that meter to go up? So let's try, instead of current, if the tube is not heating, there won't be any current. So 0 is the right number, but maybe over on this other side, D/R. D/R, and then there's this D, there's more D's. D, D. What are the D's? I don't know, I can't get a word to come out. Let's go over there. Nothing happening. Let's move this one. Nothing whatsoever on the meter. Well, it would appear to be the case that this doesn't work. It's got 2 fuses over here. How come 2? How come 2? Yeah. Oh my gosh. Holy smokes. That seems like locked in, like I'm gonna put a wrench on it. This is not the best. There we go. There we go. Apparently no one's checked these fuses for a while. Let's check it with an ohm meter just to be absolutely sure about things. It's a good one. She's a winner. Well, that's unfortunate. I found a blown fuse there. That might have been an easy way forward here, but that's not the case. So what are the possibilities here? Clearly, one possibility is it doesn't work because of an internal failure of some sort. Another possibility is I put another bad tube in here. That's very unlikely. Why don't we just eliminate that possibility? I'm going to take this tube, I'm going to stick it in this tube tester here. I have another one. And this is already set to 50 C5, I'm pretty sure. Yeah, 50 C5. Let me take the one in the tube tester. Definitely did not get warm. And let's put the power on here. And let me just move back a little. No, go forward. So very hard for you to see this. What's happening here? But I will tell you what's happening here. On the dial. Okay, looking for shorts. None. According to this. And see the tube test perfectly good. It's really good. It's a very good tube. So there's no doubt the heater, you can see the heater. Can you see it in there? You probably can't. You can't see it in there, but it definitely heated up in that tube tester. So what else could it be? You know what? I'm going to do that again. What I just did, I just plugged this in, and I could swear I heard kind of a funny sound in here. Let me try it again really carefully. Really carefully now. No, I think it's just the panel's creaking when I'm pushing down on it, and the creaking sound was making me think something was going on. Well, looking to see if there's another socket. No. Well, that's too bad, unless I should try another socket with another tube. Well, then I have to do all this setting up again. I think we may have hit the end of the road for now with this guy, because unless the tube starts heating up, we're going to get nowhere. And I'm just going to start moving these things around to see what happens. That would not be a good idea. We could look for voltage on some of the pins in here. Why don't we do that? So we'll take this out. Got warm because it was in my other tube tester briefly. Take that out of there, grab the voltmeter. Is there any voltage? Now, if there's something wrong inside this thing, I don't have a schematic or anything, you know, related exactly to this machine. How could I ever succeed in fixing it? I have no idea. We're going to put that. No, we can't put it there. We'll put it here. Put it there, and we'll go like that. So we're on 600 volt scale. I'm going to ground one lead on the assumption that that's going to be a good idea. Just going to ground it right here, like that. And then we're going to go around and see if we can find any voltage, because everything is on. Voltages are set. Let's just lay that there. And we can also check in the tube manual. Is my probe going down far enough? Maybe it's not. Maybe it didn't go down far enough. I have a solution for that. Here we are. This is a tube extender, and it has test points all the way around. So watch out, you can get a shock from this, Jim. Ooh, watch your fingers. Watch it. Turn it off. Turn it off. Give it a moment. Give it a long moment. That's a long moment. Here we go. Okay, we want to test for voltage, right? And I'm still assuming that grounding this is the way to find the voltage. Power on. Okay, just going around every pin. Anybody got any voltage to tell me about? Do not. So, but I don't have this in the test position. Let's put this in the test position. Oh, maybe that was the whole problem. Wow! I'm a winner. What happened there? What happened there? he says. So I did turn this down unnecessarily. Well, what that sounded like a relay going. I'm silent here while I think about this. That was pretty interesting. So I didn't put it in the test position before. So let's grab the warm tube, put it in there. We got some excitement out of this thing anyway. Take this off, put the meter back here. So I jump again, we go flying. Okay. I'm going to go over to the test position and see what happens. One more. This light's going down. It's a bad sign. What would cause that? What would be the mistake that's being made here in how it's being set up? With this light going down, it really means something bad is happening inside here. I think something unintentional is going on inside. And, you know, wild guess, somehow there's a short. Maybe these settings are baloney on this machine, and maybe I can't set them like this, although sure seems like every AVO tube tester uses the same chart. And they just publish one chart all the time for all their tube testers. So this one should follow that. I double check these numbers. The tube is lit. The tube is lit. What is different? What is different? So I have this on insulation test, and I'm looking for any response. Is there some kind of meter setting I don't have right? So this is the meter selecting switch. The tube is hot. Why don't we go over to this current setting? I don't know what. Here we go. Current setting. This is anode 1. Shouldn't the meter go up? I have to push this button over here. Oh, this is still on CH because if I put it on test, maybe that's how you know it's a bad tube. Rage act. Everybody would know your tube is bad at that point. Well, I got quite a distance here, but just not quite all the way. This is probably why you're supposed to read the entire manual before trying any of this stuff. Somewhere I've got some illogical setting, which should, what could that be? What about putting this meter in the neutral spot? No. No. TC1, TC2. So it really doesn't refer to these two settings here, or is it somewhere else and I've missed it? TC, top cap, TC, that means top cap. And the top cap for 50, there's no top cap, so it's 0, 0. So it's 0, 0. So that's not a problem. What about this setting up here? We have GM calibration, and so far this meter has not moved either. That's really not a good not a good thing. I'd like to see the meter move just once under any kind of test. Make that meter move. Okay, let's push the GM calibration set to I. No meter movement. Boy, and what's the run light for? And okay, can we do some of these other tests? Can we measure the heater current? Can we not measure the heater current and get it on the meter? I don't think so, actually. This is what is D/R? So over here we've got AR, SR, CHR for insulation test. DR. maybe the D stands for dumb. Okay, I'm going to stop for a bit and let this kind of swim around in my brain and see if something pops up. I can try again, try something more. I don't know. So I was thinking, what else can we do with this thing? Hey, we can look inside, see what's in there. Let's do that. Oh, another plate. Well, as usual, tube testers are full of wires. Look at this thing, great big wire cable. Not sure if I'm smelling something overheated or it's just, you know what, it's probably just opening this up. Look, this is on hinges. What's stopping it? Oh, I can see the back board swinging. Does it make sense to not do this with the thing plugged in? Right now. Oh my gosh. Holy smokes. Huh. Yeah. That is a beast. Oh man. So just looking for anything that might, you know, catch my fancy. Look at these transformers up here. They just, you know, I don't know if that's extra heat in there or not. It's quite the light bulb. This is probably a this may be serving as a resistor, or is this the big resistor the guy was talking about? Some diodes there. Diode here. There's a circuit board under here. We really can't see what's going on. Something going on in there, no doubt. How far back can you tip this? All the way back. All the way back. We can see some parts in here, capacitors. Ooh. Is it gonna fall over? Nope. Let me switch to the other camera. We'll go looking now. The first thing first thing I'm gonna do is freeze the focus, but I don't think I will. We'll see how this goes. The automatic focus is very annoying on this camera at times. Anybody look burned up? Unhealthy? Anybody look like they're ready for retirement? Other than me, of course. What is that? What the heck is that? Don't know what it is, but it's weird. It's pretty weird. This thing right beside it. Okay, don't know what it is, but it's definitely rather odd, don't you think? I would say so. A couple of big capacitors here, and these big whopping transformers. Of course, this is usually the case in these things because they want to generate a whole series of voltages with some power in it, you know, to heat the tubes up. The front panel has a switch on it here. I'm probably not going to be able to show. Where was it? Here. It's upside down, so I turn the camera upside down, and it's not upside down anymore. So this is heater volts, and you see there's a switch left and right for two different sets ranges of voltages, and I'll bet you you're just basically selecting this transformer or that transformer. I'll bet you that's what it is. And looking down through the circuit board here, that's the relay there that I was hearing. I'll bet you. That was going crazy. Was it going crazy because of defective components on this board? And so what's happening is I'm making this up. I'm turning the unit on, and at that point this relay is going nuts because of failed components here. What components? Capacitors. And there are some likely candidates. The one I got right in front of me here. Any electrolytic capacitor might be. Didn't I see a transistor in here? Way at the back there. It looks like there's a transistor. So you could have, here's one right there, right in the middle of the screen. So you could have problem with the capacitor, and then the bias is off. There's another transistor back there. And then down below is another whole board. This looks like another relay. I don't know what that is really. Let me hold still for a minute. So, there could be problems on these circuit boards that is stopping the machine from operating. What I would like to know, though, what about the meter movement? Is the meter movement pooched? Because we never saw anything happen with the meter movement. What's that? Huh. Some handwritten note. Any other notes in here? Sometimes, especially if this is a prototype, there could be all kinds of notes written on it. 13. Whew. Look at that. A, B, A. Somebody wrote that stuff. And here's a few switches here. If you like switches, here they are. Yeah. Oh my gosh. Sort that out without a schematic. Green wire looks just a little odd how tight it is here. And then here's the switches, and you can see they have a bus wires running across, and then they're making connections into these. Not the buses. These wires are going to other locations. Maybe look at that. There's a bit of a pattern here. Maybe if you look at it long enough, you might be able to figure out what they're doing. Here's another thing. What's this thing? What is this? I have to apologize too. I'm chewing gum, so if you hear the sounds of me chewing gum, that's what you're hearing. Xylitol gum. I just learned about xylitol. Xylitol. X-Y litol. Xylitol. Starts with an X. Read up on it. If you don't know what I'm talking about, to me this is a huge revelation in my life. Could have gone without cavities and tooth decay all my life if I'd just known about xylitol. Yeah, very upsetting. No dentist has ever mentioned it to me. Xylitol is a sugar substitute. It's very common. You're probably eating some of it already. On different things you eat, you don't realize it. What is this? Oh, it's a switch. Yeah, yeah. Oh, no. Is it? A and B. These are the two. Oh, these are the two push buttons on the front panel for the GM measurement. You're pushing the button, you're operating these switches here. Yeah, figure it all out. Wow. Well, of course, nothing seems to be out of sorts here. You know, what am I expecting to see? Well, that's interesting. There's nothing hooked up to this one. A2 and A1. So it'd be anode 2 and anode 1, and you could open up the link up above on the other side of the panel and then hook up an ammeter, and you can read the current. We got to find out if this meter's working. I don't want to burn it out to find out. What are these long coiled wires? Well, why would they do that? Why wouldn't they just run the straight wire over there? Must be a reason. We'll put a little bit of power on here and see if we can make the meter go up. But you know, I don't know. Is this a something like microamps to make it go up? I don't want to burn it out. No, I do not want to burn it out. So to do that, we gotta see the meter. But if I put power on here, we're talking about a tiny amount, and it's going to go back into here. Is that going to cause a problem? Probably not. I'm just going to tap it. What is this? This looks like a place where you plug your headphones in. You know what that is? That's where the light. That's the other light. There's no light. There's no actual light. You want to say it again, Jim? They must have had an idea, and they built the cabinet with this idea in mind to have a light there, and then they didn't have it. That's this metal plate covering. Oh. That metal plate is covering up a pile of wiring in here for all the sockets. All the sockets are here. Why would they bother putting a plate over it? I don't know. Okay, so we want to test this meter. I need like a really gentle supply of electricity to do that. How about something with a big resistor? That might be the way to go. Okay, I'm going to get ready to test the meter on this guy. Okay, I think I got things set up. Now you can see the meter is up a little bit. That's just gravity pulling it forward. So that's its 0 point right at the moment. I have this decade box. I've set it to 1 million ohms. I think 10,000 times 1,000. 10 million ohms to start with. I have a power supply I can set very low to start with. Everything low, and we'll see if anything will move this meter. So with the big resistor here, I think I've protected the meter. Now I'm going to end up stepping right in front here. I'm afraid what's going to happen. So power is off on the power supply. I'm going to set it minimal. Put on volts. Flip it on. Watch the meter. Nothing happened, eh? I would say nothing happened. So we got virtually no power coming in. I'm going to turn up the supply voltage. 10 volts. No movement at all in the meter. Now I'm going to leave the power on. I'm going to start reducing the resistance here. Don't know which way the meter's going to move. It's going to move. Should be moving by now. Okay, so the resistance I've got in here is 100,000 ohms. 50,000 ohms. Flip the switch on and off. This looks like the meter is burned out. Going down, this would be 33K, 15K. Okay, now let's do this. We are now at 10,000 ohms, 6,000. There's no movement whatsoever. Now there's a chance maybe my connection's not good here. Suddenly the connection will make the meter be gone. So we're going to put this back up on a very high resistance, and I'm going to try to see, just to make sure these wires have remained connected. So I have one lead going to the negative terminal, the other lead going to the positive terminal on the meter. should be. There is no reason why this meter shouldn't be reacting, I think. So what we're going to do is get another meter. Get another meter and check to be sure the voltage is there. Right on the terminals of the meter we're testing. So I'll put this guy on 20 volts here. What happened to my meter holder? Okay, I'll put this one over here. That's not good. Can't really see it. Meter holder guy. Okay, you can see it there. I'm going to step in front of it when I do this. Okay, let's do this. So what we're doing right now, we're just checking to make sure the voltage is making it. Some voltage is making it to the meter. And I'm going to want to, wow, this is so big. Big piece, I'm going to rotate it a bit. Making sure the meter doesn't suddenly jump. We have this set to we have this set to a very high resistance, so I think we're safe. Okay. Right on the terminals of the meter. So we got 0.44 volts there. So voltage is getting right onto the terminals of the meter. And the meter's not moving. Oh, I think the meter's burned out. Can we read the resistance of a meter like this? I think so. I think so. Let's turn this guy around even further. I'll turn this off. Turn him around. That's what it boils down to. Busted meter. And this. Take our meter here, put it on what? So we would expect a pretty high resistance there. So I'm going to just leave it like it is. 200K is the scale setting. I need a meter stand. Let's try it. Can you tell I'm rushing now? Rushing, that's bad. Don't ever rush. When you rush at stuff, bad things happen. There. Now I got to disconnect from the circuit. You have to disconnect from the circuit. One of these here. The meter is disconnected. So the other meter doesn't like it. 200 million ohms. Oh. What do you think of that? Does it have a capacitor in it to dampen? Does it have a capacitor built into it? No, this is going the wrong way. Did the meter go up? Did the meter go up? I sure would. Okay, try this again. So the movement is not reacting at all. So that's, whoa. Oh no, what is this? It's my meter. It's the meter itself. You bad boy. Let's give it another meter.
bring on the Allen meter. Okay, Allen meter. Inside here. Bench is getting crowded with junk. That thing's grabby. Okay. We're going to clip one. No, I'm going to clip it on. Because then I have to question the clip. 6 megohms. More than 6 megohms are there. That's the top. 60 megohms. No, you know what? The meter is pooched on this. That's what we're finding out here. Let me reverse the leads. Could there be a diode in there? I doubt it. Reverse the leads doesn't do anything. Oh, that's the end of the story. We have reached the end of the story. I would say 95% certainty that the meter is not going to work. With the meter not working, this whole unit is kind of useless. That's really a shame. That's really a shame. But I think that's a situation. And I think that's a common thing with instruments with meters on them. The meters can get damaged either by a failure in the unit or somebody like me not knowing what they're doing and flipping the controls, and the next thing you know the meter's pinned over and gone. I'm very worried that this meter is going to go that way on this device, because after this has been on for about 45 minutes, some charge is getting somewhere where it shouldn't get, and this meter just goes right over and gets pinned. Once a meter's pinned, you can't tell how hard the pinning is. It can be hard enough to bend the pointer, or more likely just burn the very delicate meter coil out that's in here. So I'm quite worried about that one. Okay, that's too bad. That's too bad how this is going to end, but it is what it is. So thanks a lot for watching. As you must realize, I can't guarantee the outcome of anything I do in the shop here. I have no idea what's going to happen when I get into these things. So thanks a lot for watching, and enjoy your day. See ya.